couple chapters ago, we did similarity and similarity for area. Now we're doing similar solids. And to go from a similarity ratio, which is a length ratio, to an area ratio, you have to square the length ratio. So this is now 4 to 9, whereas it was 2 to 3 of these similar solids, these two spheres. The surface area would say 4 to 9. The volume ratio is cubed of the similarity ratio, so that's 2 cubed is 8 to 3 cubed 27, so it's 8 to 27. And so to go length to area, you're squaring, length to volume, you're cubing, volume to length, you cube root, area to length, you square root. So here's some examples. Okay, here we have two similar cylinders. The surface area ratio is 49 over 81. So that's an area. If you want to get a length ratio, which is the similarity ratio, you have to take a square root. So that's 7 over 9. So similarity ratio is 7 to 9. Over here, our volume ratio is 125 to 512. If we want to get a length ratio, the similarity ratio, we need to take a cube root of 125, which is 5. So that's the cube root of 125, and then a cube root of 512, which is, I believe, 8. So the length ratio would be 5 to 8, and the similarity ratio, 5 to 8. Okay, over here, are these solids actually similar to each other? So we have to do a little ratio test. So is 4 over 3, is 4 over 3 equal to 8 over 6? And indeed it is, so that would be yes. For this one, is 9 over 12 equal to 5 over 9? 9 to 12 equal to 5 over 9, and no, it's not. So number 5, those are not similar cylinders. Now as far as what do we do with these ratios? Okay. Well, we can use these ratios to calculate some unknown quantities. So for instance, in number 7 over here, in number 7, we have a surface area of 25 and another one of 36. So this is 25, this is 36. Our length ratio, therefore, is the square root of those, so 5 to 6. Then we go from length to volume, you cube it. So 5 cubed is 125, 6 cubed is 216. So we have a volume ratio of 125 over 216. The larger figure is given. So larger is 216. So the smaller one we don't know, so we'll call it B. And if we solve this, we're going to get 125 for our answer, clearly because these would just cancel out. Now for number 9, let's change this around now. For number 9, we're given again an area ratio. This time it's 72 to 98. But before we try to take in these roots, we can reduce. So we divide both top and bottom by 2, and we're going to get 36 over 49. So this is 36. This is 49, take a square root, you get 6 and 7 to get to the similarity ratio. To go to the volume ratio, you cube it, 216 and 343. So then we have 216 divided by 343 is equal to B, we don't know the smaller one, divided by the big one, 686. You can cross multiply, but it's much better just to cancel these. You get a 1 here and 2 here. And then when you cross multiply, B is equal to 2 times 216, which is equal to 432, and this would be 432 feet cubed. Now, the problems down here are pretty similar, except you're given volume ratios to start, 8 over 125, and you want to set up a surface area problem. So we go from volume to length, you cube root it, cube root of 8 is 2, cube root of 125 is 5. To go from length to area, you square it, 2 squared is 4, 5 squared is 25. Then we have 4 over 25 as our area ratio. We are given the surface area of the smaller figure, so that's equal to 4 on top and then A on the bottom. When we solve this, and we get A is equal to 25. That would be 25 feet squared. Let's take a look at number 12. For number 12, you have 125 over 1,000. And first let's reduce it. So 125 goes over 1,000 exactly 8 times. So it just becomes 1 to 8. So this ratio becomes 1 to 8. You take a cube root of 1, take a cube root of 8, you square 1, you square 2. So you've got 1 over 4 is equal to 150 over A, because you're given the smaller one. And so we cross multiply, and we get A is equal to 4 times 150, which is 600 centimeters squared.